Okay. Hello, hello. Well, the lights are looking exceptionally bright in the background. I think it's a cloudy day out. Either way. Scorpra, congrats on the first. The competition has been fierce the last, like, 2 weeks or so. I'm surprised you're not getting yelled at by Mr. Eldritch, to be honest. I was surprised that Spetri is, MIA, but maybe he's busy. But yeah, hey Scorp, hey Central. Usually Twitch sends a notification 20 minutes after you go. That's annoying. Normally, like, is it like the mobile notification or is it like the email or like which notification is it that's always late? So if I have like the Twitch page already open, the one on mobile, oh okay. Those ones I don't use, so I don't have any personal experience. If you already have like the Twitch website open, the ones that pop up on the upper right are usually like reliable for me, but that's probably a lot easier to do than a mobile push notification. Did I have something else waiting for me? I don't think I did. I'm going. YouTube is live. Ideally, yes, it is. Okay. Did I have much in for mobile? Oh, interesting. Um, I guess I'm probably like, what would I say I am? I think I'm probably like 70% desktop, 30% mobile. I'm usually watching on desktop, and then if I have to get up and I don't want to miss what they're about to say, I bring it up on my phone. So on my phone if I'm doing like, or if I'm like cooking or something too. But usually I prefer the desktop. I guess we're about to explore the physics of jumping onto a mattress. You keep, yeah, my pad central. I'll try and talk quieter. Waffle, it's been a minute. How have you been? If you're having a good what Thursday? Let's say Friday. That's not for Friday. Yeah, it's been good though. That's good to hear. It's Friday if you wish hard enough. True. Or if I get on a plane and go to like Australia or something. Jump out of a window. I jump with zero initial speed. That definitely makes sense there, but let's go with it because it probably makes the problem easier. Wait, okay, I jump out of a window onto a mattress. Is the building on fire or something, or why am I doing this? So the mattress can be treated like a spring with a constant K. You fall distance H before hitting the mattress. I'm wondering the same thing, Central. It's more like falling, I guess. Like I just tip forward. Fall distance H for hitting the mattress is the maximum compression distance of the mattress. What is the maximum force it applies to you? Ignore the change in gravitational potential energy during the compression. Okay. But oh, you know what? I probably want to do some analysis stuff today. That could be later though. What is the probability of me finishing 31 chapters in 48 hours? Uh, so that sounds like a lot of chapters. Depends how big they are. I think it's very close to zero. At least one probability. Ugh. Um, good enough for me. Godspeed, Joseph. Hey, underscore. So I guess what we want... I'm going to mess this up, aren't I? But like, our initial gravitational potential energy is mgh. Why is show and tell so expensive? Because I have very few... Is it my penis? Yeah, I that's the redeem to get a dick pic. What is that emote? Oh, that's hilarious. I love that. And you know, the dick pic can't be cheap. You know, it's very in demand. No, I just don't have that many interesting objects. Waffle, cover your ears. I wish my comment was as funny as that emote. And that emote is pretty great. I'm being gross, Waffle. You should ignore me. Ben is... I'm trying to think what I would even show if I do. I mean, okay. So now to... There you go. At least when I'm talking about something like that, you know. My redeem's own. Oh my god, dude, those emotes crack me up. Grow up? Never. I think the equation is as simple as this. I should be mature as you are true. Yeah, well, when I try to think of like the most mature person I know, you're the person that I think of. For most familiar, did you win? You sure did. The left side is gravitational potential energy. The right side is spring potential energy. We are not 70. 50 streak? Oh my god. That is crazy. You're streaking. Twitch stole my streak again? Oh, frickin' Twitch. Or you just didn't show up? Yeah, you just never watch my streams, essentially. You're just not dedicated enough. That's what I choose to believe. This feels too simple, but like, don't we just isolate X here and that's the first part of the question answered? I'm not number one. USA, USA, USA. Bezos doing... Yeah. I think Jeff Bezos personally deleted your watch streak central. Not a true Dawn enjoyer. True. Bald guy. Oh wait, I thought you were insulting me. It's like, wait, I'm not bald. Like the cunt part, you know, sure. Also, language warning. That'd be kind of funny if you did call me that, to be honest. Not yet. I mean, I will be bald one day. That's just the reality of my genes. My hairline is not doing great already. You'll be good. I don't care. It's not a family-friendly stream. Change my... That's true. Yeah, I should just get new jeans. Maybe some Levi's this time. The maximum force happens... Ooh. The maximum force happens when it's fully compressed, I think. Yeah. And so we would take this compression distance x and multiply it by k, I want to say. Because that's just the force due to a spring. Your above statement as a biology student is troublesome. Yeah, the fact that it wasn't a statement. Nah, it's fine. You got this. Okay, I guess this is my answer for part A. This feels too simple. I feel like I'm gonna... like... realize I made some really stupid mistake when I go to check the answer. Schrodinger's genes. He can quantum D's and... oh my god. Walk in? I got things in my chat like quantum D's nuts. I'm supposed to lock in with that happening. Oh, what's problem 4.2? Does the one if you cut a spring in half? No. Wait, 4.2. This is 5.2. 4.2. Okay, so instead of cutting the spring in half, we're doubling the spring. But what was the result from 4.2? If you cut a spring in half, whatever time you're in here, maybe there's a common cause. No. Hey, $10. What's good for dinner? Birthday cake? That's true. That is the best dinner. Okay, so if you cut a spring in half, the spring constant is multiplied by 2. And so if we double the length, we presumably cut the spring constant in half. So now if we have, instead of one mattress, we have n mattresses, that means that we're cutting the spring constant by 1 over n. The word correlation came to me after I sent it. Thanks for pointing out my stupidity. No, I mean, always point out central stupidity. It happens a lot. It does. You're not even arguing. Now we have 1 over n times the original spring constant. I think it's the only difference. So is the word central. All right, so I assume we just solve this for k, or sorry, for x again. And then the same maximum force is just gonna be k times that. I swear, I'm gonna like check the answer and feel so stupid when I realize I did this wrong, but like I don't see what else like it could possibly be. You change generalization so it's spelled correct. Generalization. No, that's right. Jumping matches is fun. But I mean, I agree, but this time we're jumping out of a window with 0 initial speed, which makes perfect sense. Do you guys spell with an S? That seems so wrong. Get your own language to fuck up. True. Well, as it turns out, there used to be many languages spoken in America until the British showed up. So the S, to put it back, no, I hate the S. Or yeah, the S just feels so wrong. This is number 11. But it looks so right. My mind is telling me no, but my body is telling me yes. Apparently that's the British spelling. Generalization. Can we like, how does Oxford spell it? Wait. Ugh. How does Merriam-Webster? Do they give the other spelling? Wait, not meanings. Spelling. It feels stupid to spell out a word and then put the word spelling after it. Oops. I didn't mean to click on that link. English words do not end in the letter V. Wait, what? There has to be an English word that ends with V. I can't think of one, though. No, your language is the other spelling. It's your language is the wrong spelling, I should say. See, even Wikipedia agrees that it's a Z. They don't even address the whole S thing. See, I'm doing Control F with an S. It's nowhere on here. Generalization, S or Z. Wait, even generalize has an S? No, it's clearly a Z. Can you not think of a single word ending in V that's not short? Wait, I can't even think of a short word that ends in V. See, even Canada, it's on our side. Gov, rev. Oh, like revving an engine? Is that a word? Or is that like slang? Rev. Text or speech tech. Okay, what? Okay, no, I should go. Okay, this is. I should go back to the physics problem, but like I need to know. Rev. It is a word. Okay. It is short for revolution. Canada's... Oh, God. Ugh. Revlib? Is that a word? Revlib? No? Okay, wait. Words that end in V. These look like names. Improv. Well, that's short. That's short for improvisation. These are all like shortenings. That's just an acronym. How is ATV a word? This is really annoying. Shiv. Is Shiv short for something? I can't think of what it's short for. Rebel is a thing. Oh, okay, okay. It's slang. Hmm. What the hell is gov? Is that short for like governor? Like the British thing? Thanks for repeating me, you fucking parry. Ugh. Government? Oh. But don't like, isn't that like a British like stereotype? Like you call people governor? Oh, you said G-O-V. I see, okay. Yeah. Okay. No real words end in V, apparently. That makes me uncomfortable. Oh yeah, I was looking at the answer to this. What wasn't I? So okay, it is just that simple. My mind has been blown. I don't come here to learn. I know you actually like learned something that's terrible. That's not the point of the stream. I try to make people dumber with my stream. That's not possible. Well, just look at yourself. You were, oh hey, okay, you're DUM dumb. There you go. Hey, Arav. Well, it's okay, Central, because you're DUM. Tomorrow's your English exam. Ooh, good luck. Get back to work. I'm working on it. Oh, did I mess up the end? Wait, how is there an N on the bottom? Oh no, I messed up an N. Okay. I had the right idea though. I just forgot. Don't ask me for help with the English exam. Yeah, I'll tell you to spell things with a Z instead of an S. Okay. I know. How could I miss the end? Wow, you're stupid. I didn't even see that. Yeah, it's right here. What I forgot. Also, hey, this was let's just do this in 2 steps. Delete you. It's 1 over n k is the spring constant in this case times the compression. 2 mghn over k. And that simplifies to nearly what I wrote, but there's an n on the bottom. I was just about to I was just wondering if I should make that disclaimer central because we just kind of go off on each other all the time. For anyone who doesn't know, Central and I have played a stupid amount of DayZ with each other, and that's just how we communicate. We just insult each other. So yeah. That's the lore. Hey, Colton. Oh, and this was hey, thank you for looking at Silverbird's question, by the way. I feel bad that like I immediately like said something that was wrong. It's like, I probably don't know this, so I'm just gonna see if someone else answers it. Got into his car one day, he crashed. That's how we met. I've not crashed every car I've driven, okay? Mind you. But yeah, when we first met in DayZ, me and another dude had just found a car. He like walked up. And then we somehow made friends. I think he was initially going to try and kill us. But yeah, I drove the car and I crashed it. But we didn't die though. With me in there, you have? Okay, well, that's because I, do that on purpose. Oh yeah, Papadoria. Yeah, ooh, the Despos link won't work in the YouTube chat. It would work in the Twitch chat. I don't know if you're in the Discord, you could put it there too. You drove it, it got stolen, so who's right? True, yeah. Oh yeah, I got stolen at the in Novi. I don't know how like I remember that day so well. That's the day my life really went downhill. It's all been terrible after that. And that kid is how I met your mother's story? Yeah, Waffle, basically. Do I still have your question up somewhere? Maybe I have it in my other file. I knocked you up, yeah. Discovered 2 new formulas. Oh yeah, here it is. That's nice. Yeah, that's about the best response that is possible to that statement. Waffle. You're gonna be weird somewhere else for a while? Alright, see you, Central. Discovered 2 new formulas. Okay, so this is Piggy Master on Twitch or Papadoria in YouTube. We work on this problem, I think, on Saturday. The question is really more about parts B and D. Part B, I got an answer for. Part D is pretty freaking tough. Hey, Raze. Let's look at this Desmos link. Actually, let me get the problem text in chat as well. Will this fit? Okay, yeah. Let me get it in the YouTube chat too. Guess if YouTube will let it fit. There we go. Okay, and so what's up with this Desmos link? You found 2 new formulas that do an equally good job of summing up the digits of a number. And well, in terms of getting the right result, it seems. I goes from the minus ceiling. Ooh, starting I from a negative index. Log base 10 of x. So log base 10 of x gets you basically the number of digits of x if it's written in base 10, which it is. I think it's number of digits like -1, but that's okay because the summation presumably takes care of that. And I assume for a reason that we'll see in the formula, we're starting it from negative and going up to 0. And we're taking the number x, multiplying it by 10 to the I, flooring it to get rid of any decimals, and then we're taking it mod 10. It's probably not that important for me to understand the actual formula because it seems like it definitely works, but I just want to see if I can figure it out quickly. Colded, yeah, sure. You can be right after we talk about this question. This question might be a while because it's a tough question, but you can be right after. Says instead of modding, wait, you can do floor. Oh, right, you're dividing. Oh, nice. Okay. Yeah, that's right. Okay, so that's why I is negative. So you're basically cycling through each of the digits. Okay. I think I more or less understand it now. Yeah. In mod 10 just takes the ones digit. Okay. Now this one is floor x minus a similar looking sum. It's kind of funny how the second one does look easier to deal with because there's no mod involved. If we're going to go this route though, I need to look up an example of integrating the floor function. Wait, a related problem, a related problem. The whole chain of related problems. Haunted floor functions, yeah. um, I guess let's mess around with this. Oh, let's see what this link is. Number 6 has the integral. Whoa, this is just a fact? I didn't think that there would be a formula that clean for all non-integer x. So that is an issue. I think. I mean, I assume it's an issue. Hmm. Okay. So I get maybe let's work with some too and see if we can squeeze anything out of it. So we're worried about the integral from 0 to n of floor x minus sum to -1. And so this isn't unbounded. So I think we could safely split the integral up into two separate problems. Like, I don't think we have to worry about diverging. The first one, we can split up in a sum from I equals 0, I guess, to n of I to I plus 1. And I guess we only go up to n minus 1. Because the I plus 1 will take care of that. And presumably we can just evaluate that first integral without too much trouble. Cole, did you agree with the n minus 1? Okay. The second one, how the hell would we split that up to be anything that's remotely nice? You know, it suddenly got brighter. I thought today's just gonna be a cloudy day. Let me go close my. When is it possible to switch summation integration. I'm not entirely clear on that. I think it depends on the function inside being having certain qualities. Oh, I never heard of OSF. Uh, I mean, for the sake of evaluating the integral, oh, well, yeah, that's a good question. How does that work? Okay, at least the first integral, like, this is just a rectangle with height x and width 1. So it's just going to integrate to be the floor of x. So, like, that's a desirable part of using the second summation. Like, at least this part of the formula is relatively easy. This part is still kind of difficult to contend with. Yeah, I especially wouldn't like switching when the summation involves x and we're integrating in terms of x. That just seems like a no-go. Wait, this doesn't feel right. Did I do that? Did I think about that integral correct? Rectangle of width 1 and height floor x. Maybe, I guess I did. But isn't this just gonna end up being, it doesn't feel right that to get n minus 1 times x, or just n times x. It's equal to I. That's, yeah, okay, that feels way more right. Thank you. Thank you, Colton. So the difficulty I was having the last time too is that if we want to break up this thing, I think we had to go by powers of 10. I think. I dropped a 9, by the way. I don't. I'm getting confused where we have to deal with the ceiling and we have to deal with the floor, and I don't know if that means we're gonna get two more summations or what. Would it be easier to think about integrating term by term? Like, let's bring the 9 all the way out. And instead of a summation, what if we just think about things term by term? I need more room. We eventually end up with 10 to the minus 1 x dx. And this is a finite number of things, because reasons. X ranges from 0 to n, that's why. Does this make it easier to think about, like how do we split? We might need individual summations for each of these terms. Maybe that's the issue. I don't know. I'm trying to think about. Oh my gosh. Like, when does the floor function cause a jump with just our first term? Maybe it's worth graphing just that in Desmos. Oh, I doubt it, Papadoria. This one just seems a little bit too difficult. I don't know if Wolfram Alpha can handle floors and ceilings. We could try it. I never tried to integrate something like this in Wolfram. Do they have... They should have floor programmed in. If I give it... Just as a test, 0 to 100 floor X. Does that behave as expected? I should maybe give it... That doesn't seem right. Let's give it a smaller number that's easier to verify. 10. Because 4 plus 3 plus 2 plus 1 plus 0? Okay. That seems proper. Wait, can't Desmos do integrals now? Let's try it as a... What does Wolfram Alpha do with an indefinite integral? Oops, that's not what I want. Because we need to integrate this... I guess not indefinitely. What? Oh. I mean, can we just we'll assume that n is a constant. Let's find that out. It doesn't like that. Instead of the I equals ceiling log x, you can substitute r in the new function, send to the minus ceiling log x plus r. Gotta leave? Okay, I might switch gears to Coldit's question in the meantime then, Papadoria. Oh, so you're... I don't know. I mean, maybe... I don't... I'm not sure if that would help, but you're saying, like... Make a new summation where r goes from 0 to ceiling log x minus 1. Maybe we want r equals 1. And like, would it be like 10 to the minus r times x? Maybe like that. I mean, maybe. I'm not sure if this is better or worse, but this seems like you'd be allowed to do this. Academy of Useless Ideas, thank you so much for the raid. Welcome in, everyone. How's the rest of your stream? I was like weirdly like, or not weirdly, but I was like really into those like puzzles that you were looking at. Oh, so with what? Equals 0. What's the benefit of doing that? I feel like we're just getting back to a summation where I kind of don't want one. Part of your ideas usage probably join the academy. Uh it's a really fun stream. Um we were talking about like a mathematical like philosophy, and I actually got interested in it. And I usually don't see the point in anything philosophical. But there's some really cool discussion happening over there. So I highly recommend that everyone here goes and follows. Dan, yeah, it's the truth. I just like it's like, sure, it's a difficult question to answer, but why do I care about the answer in the first place? I know that's how I feel very often. Pointless but fun. So that's the point. I will be truly angry to you. It's only fair. That's fair. I can't debate that. I should start from 0 right as the line prior. Yeah. I agree that this is equivalent to the line above it. I don't see how it helps, but I think it's equivalent, yeah. We love useless ideas. Yeah. So for you or anyone else who's like just joining us, we were the other day a YouTube chatter. Well, actually, both he's both YouTube and Twitch now, but Piggy Master on Twitch or Papadoria on YouTube asked me this problem here and was particularly interested in parts B and D. And what it basically amounts to is trying to integrate a crazy floor function thing. And so we've been trying to wrap our heads around that for a good while now. I found an answer for part B because it's a simple enough pattern. Part D is basically part B, but to an arbitrary stopping point. And that's been the difficult piece. The person who asked the question did like step out for a minute, but yeah, so that's that's something that Papadoria found. And so actually he found two different possible definitions for S of X. They do involve a summation, but these both get us what we want. Like these two functions are the they get you the same results. So the second one looked easier to integrate, but easier is in quotes because it's still very difficult to integrate. Yeah, exactly. Like rectangles of width 1 even, so it's even easier. Um, it's just that there's weirdness that like the pattern from 0 to 100 is like really clean. Like you start doing 0 plus 1 plus 2 plus 3 plus 4 all the way up to 9. And then it's the exact same pattern from 10 to 20, but you do 1 plus 2 plus 3 up to 10, and then 2 plus 3 plus 4 up to 11, and you just keep increasing by 1 each time. That's an easy enough pattern to generalize. But once you get to the next power of 10, I think you get a completely new pattern that's similar and should still be able to make an arbitrary formula for. But it's a little bit more difficult, I feel like. Because then at 200, you have to like reset. It resets each 10 because the numbers are written in base 10, basically. Because we're adding the digits of a number. Do I still have it copy pasted? No, I don't. So it's always difficult to like always show a problem at the same time, but like that's the original problem statement in chat. In case anyone wants a copy of it. Yeah, and so I imagine like even if we would, I didn't do it, but even if we did go through the trouble of making a formula for numbers like 100 to 999, we'd go back to the drawing board for once we get to 1,000. What a Fourier series would look like? That's an interesting question. But it's still gonna be a very similar pattern. It goes right back to 1? I guess that makes sense. It seems maybe it's all just different versions of. I mean, I guess like I kind of knew that it's always just different versions of 1 plus 2 plus 3 plus all the way up to 9. But it's how many of those do you have and what's being added, I guess. Oh no, because here for 1200, wait, no. So yeah, this problem's been like a bear. Hey Joel. You have a polar function and you need to find the arc length. Oh no, you have a parametric function, you need to find the arc length. So I do think I might take a break from the problem that we're looking at right now. But Cole did ask a question before you. Let me see. Okay, I think Cold's question, it looks involved. And I think, Joel, your question looks shorter. Let me see if I can get through. I'm gonna try and get through Joel's question relatively quickly and then do Colded's, and then we'll come back to that integration business. Hey Brian. Maybe once Papadoria's back. Uh yeah, this is definitely some Calc 3 stuff. Let me I need to there's just a formula for this. I just need to remember what it is. Arc length. It might be in Calc 2 even. Yeah, it actually oh yeah. Arc length with parametric equations. This is the formula. Without having to think too hard about without having to try and like derive it again. Use the formula. And then the question is this. Okay. So everyone always asks where F's X is, but never where X's F is. That's true. Well, as long as you don't think about inverse functions. I think. I don't know. I'm just kind of saying things. So let's start by finding dx dt and dy dt so we can plug it into the formula. Dx dt, we have 5 cosine t. Okay, so minus 5 sine t minus 5 cosine t. And d... Oh, this is such an annoying integral. Oh, no. Hopefully we get some simplifications. How many calcs are there? 1, 2, 3 is very common. Sometimes there's a 4. Other universities sometimes call it differential geometry. And that's about as far as they go, as far as I know. Made a mistake. A bunch of squared and sine and cosine. Yeah. If the integral takes too long, I might just need to phone it in and use Wolfram Alpha. So I feel bad that Cold asked the question first, but I'm working on this first. Let's see what happens when we actually plug things in. I don't like that we have different phases. Like, you know, different arguments for the angles, but what did I write here? Who wrote that? It couldn't have been me. Talking about when infinity plus infinity is pretty fun. Yeah, the rules of infinity are kind of funky. Oh, why is it that easy? It won't be easy for forever. 0 times, yeah, 0 times infinity is undefined. 1 to the infinity, you would think is just 1 times 1 times 1 times 1 infinitely many times, but it's actually undefined also. There's a bunch of like weird, they're called indeterminate forms. If you want to like look more into them. But that's the general word for all those weird kind of things that we don't quite know what to do with. Okay, we've got a whole bunch of multiplying out to do here. 25 sine squared t minus 10 sine t cosine 5t plus 25 cosine squared 5t. So we get from the first the second one, I'm going to do a separate line. 25 cosine squared t minus 10 cosine t cosine 5t plus 25 cosine squared 5t. Oh, this looks like a fraction. It's not a fraction. Okay, I'm gonna write it like that to avoid it looking like a fraction. So what we want to do here is hope that we get sine squared plus cosine squared with the same thing inside the parentheses, because that gives us 1. So I see we can group that and that to be a 1. Thank you for the good luck. I'm gonna need it. Wait. Why does that say Donda's math on the thing? Thank you so much for the Donda's math. Oh, I couldn't read it right in the OBS preview. I can see who actually did it. Yeah, I know. Thank you so much, Unlocked. I really appreciate you put my name in it. Fair enough. Tomorrow, me and Hardlocked are gonna be playing. Like, I looked for terrible games on Steam, and Hardlocked was brave enough to say yes to trying some out with me. So, be excited for to tomorrow. It's not very square. Okay. Can I go live when I'm closer to my math exam? It depends on when it is. Oh, okay. Hey, Papadori. Sorry, I'm switching gears to work on this problem, and then I might want to work on Colded's problem also. Could you do math on meth? Probably. Well, probably not. Now that I think about it, for more than a split second. We get 1 minus 10. Oh, you need this. Yeah, cool. I was just wondering about an identity like that, but we have sine, cosine, and then cosine, cosine. So I don't think we quite have that. 1 plus 1, 2. Celine was good enough to put up with huskies. They're beautiful dogs. Yoki, if you're such my husky throws a temper tantrum, people call it cute. I think they're adorable. That's why I have those as my alerts. I would never want a husky for myself if it's acting like that. A calm husky I would love. But yeah, I wouldn't want to put up with a husky who's actually doing that in real life. And I'm wrong. That's true. I have been wrong a lot in life. So we do have product to sum formulas. I don't know if those are even a good idea or not, though. Write them in exponential form, simplify, take the real component. Honestly, that's the real answer, Territar. Okay, I'm gonna try the product to sum formulas, I think, but if it's not these, then I might need to plug it into Wolfram Alpha. And I feel bad about doing that, but there's a couple of problems on the docket, and I kind of feel like I need to get through as many as I can. So, so we have a sine t cosine 5t. So let's look at that formula. No, then we're gonna get 6s. That can't be right. Well, maybe it can be. If we also do this formula on the cosine squared, no, that can't be right. No, I don't think this is right. I'm going to open up until we see what the technique is. Oh. Wrong variable. It's like fundamental theory of calculus. No, you can't give me a numerical answer, Wolfram. Not on this problem. Why won't it let me copy paste? I can't highlight things. Oh my god, bro. I'm gonna take away the bounds if you do that. Okay, so Joel, this integral is probably not easily possible. What a function. So I'm glad I went to Wolfram here because it doesn't really simplify in a way that's helpful to integrate, as far as I can find. So I don't know what you're supposed to do with that as a student, but I either maybe there's an error in how you type it into YouTube chat, or I don't know. Um, it came from this. This is the original problem statement up here, Jasu. So yeah, I'm sorry that I can't like say much more about it, but I don't think this is this integral doesn't seem very possible to me. um okay, I maybe we'll try with Colded's problem now. These problems are normally not very easy. And then we'll go back to Papadoria's. So I'm sorry, Papadoria, that it's always hard to figure out what order I should do questions in. So this makes me remember my friend used to send me non-integral functions before exams to waste our time. Oh my god, that's so mean. Is there a tetrahedron A, B, C, D in which another tetrahedron question? This is a regular tetrahedron. Oh, what? These look like linear combinations for like a greatest common factor or least common multiple, whatever. I don't have the background to do this problem though. I This looks like a random walk problem, and I've never done these before. Markov chain problem? Oh, maybe, yeah. Draw it out. I mean, some sort of recursion. I guess we can start to look, but why do they give us the length? Surely that's irrelevant, right? The bug starts at A. So presumably, if we're starting at A, well, would P0, would we define that to be 1? Because we're at A always. And then P1 is 0 because we have to move away from A because we're at A. But then P2 is where it actually gets interesting. Is that just a 1/3 chance? I guess if you were to flatten out the tetrahedron, you would draw it like this, where all 3 nodes are connected to the other 3 nodes. I guess it'd be like that. And all these edges are equally weighted. Binomial, Tertar says. A Markov chain, I don't really... I've seen them before, but I don't know enough about them to explain them. It usually involves like some kind of matrix of probabilities. And you take powers of that matrix to represent like steps in a game, or like turns in a game. I just don't know how to actually do that, because I never have done it before. I think you would... I think you would probably make a matrix. I think it's like maybe be 4x4. And each of these probabilities is, I don't know, would you start from the row? Like, I think you would think about this as like the entry here. If you start from A, what's the chance you end up on A, which would be 0? I think that's how you set this up. And then this entry here was probably that if you start on A, that you end up at B would be a 1/3. So would this all be a 1/3? But 0 on the diagonal? I'm going completely off memory of other Markov chains that I've seen. So this could be wildly wrong. Take the vector P, that's probability of the bug at any position. Multiplying the matrix gives you the update on the probability. Hmm. And so you would have some other vector that represents your starting position. Presumably you start at A, it'd be like 1, 0, 0. And then as you continuously multiply this matrix into the vector, or like, you know, if you multiply it in once, you get the probabilities that of where you end up after the first turn. You multiply it again, it'll be after the second turn. I know that 243 is a power of 3. 3 to the 5th. Uh, 81 and 27 also in that one. I guess... Is this easy to take powers of? Because we would need to get up to, like, the 7th power or something. Potentially. It might be... Wait, so what happens that... Let's just do one... You probably diagonal the matrix so that taking powers is easy. Sometimes it's easier to look at the equation and figure out some recursion to solve it. And some by the... Yeah, I don't see why the length matters either. I need to explain. You found someone on Stack Exchange? Yeah, if you want, you can post the link in the Discord, I guess. Hey, Silverbird. X plus 1 over x to the n, the coefficient of each term. It's the probability of being at its respective node? Is that like a generating function? Tertar is suggesting... I'll put it on screen. It looks like a different approach. That I don't know how to begin to evaluate. But I want to just like share in case it triggers something. Or an idea from anyone. Two eigenvectors are 1, 1, 1, and 1 minus 1, 1 minus 1. That's a start. 4x4 matrix, you probably use Cayley-Hamilton to solve for other values of the matrix. Might be overly complicated. Huh. And then Colda, or the person who asked the question, just sent a Stack Exchange thread. It looks like the same problem. So let's take a look at the Stack Exchange thread. Hey, I got the Markov chain, right? But I assume the person did this like numerically. Like, you know, like not by hand, this power of 7. Oh my god. Oh. Oh, yeah, Fizzbuzz. That's fair. You can square the square to save some time, can't you? The only thing that matters is what happens at A. So they reduce it to a 2x2 matrix. I was wondering how they got that N matrix. Because I was presuming the answer to the question would be the result of all three of these probabilities added up. Or all four. So state representing the bug being an A and the bug being not. That makes sense, yeah. Presuming it's N11 though. Or no? It's still to the power of 7. Okay, I mean that's a lot easier to compute. So instead of doing a 4x4, that seems like reasonable. Instead we do A, not A, A, not A. So 0, 0. If you're at A, the probability going to not A, isn't that just 1? Wait, yeah, okay, it is. And then if you're at not A, wait, that other zero's wrong. You have a 1/3 chance of going to A and a 2/3 chance of going to not A. Okay, and so that's the same matrix they got in the thing. And computing that power of 7 is probably more realistic by hand. Is Kaylee Hamilton. The eigenvalues, the eigenvalues of that 2x2 are 1 and minus a third. Wow. Hey, Arhan, or Ron. Thank you for the kind words. I don't know what these K's are. Going from A to A in n steps. Can find them knowing 2 of the values. Interesting. Yeah, I haven't seen Kaylee Hamilton before. I wonder, but didn't we get that numerically? The 1/4? I guess you can probably guess that it's 1/4 because you have 4 vertices. Let me maybe try to explain it a bit better for Colded. It's going to be hard to express because I only kind of know this, but the point of having a matrix like this Colded is that it tracks every possible, or like, it tracks the probability of whatever happens next, no matter where you start. And you would think about this as starting from A, like you go from one of the rows to one of the columns. So if you start from A, the probability of ending up on A is 0. If you start from A and go to anywhere that's not A, then that always happens, so it's a 1. It's a little bit more interesting for the not A case. If you start from anything that's not A and you go to A, that's just 1/3, because there's 3 other possibilities, or 2 other possibilities. And then from any not A to another not A is 2/3. And so if this gets whatever happens next, you can get what happens after 2 turns if you multiply the matrix twice. And after 3 turns, if you multiply it 3 times. And that's why we're talking about powers of the matrix. Yeah, the thing I just don't like about it is how you conclude the limit part without a numerical simulation. Unless you're just guessing by the construction of the problem that you have about equal chances of ending up on any of the 4 vertices. Yeah, basically that, Colded. And so I probably look up resources about Markov chains um, for a better explanation, but that's my kind of like very basic understanding of what they are. And so if you did the first way, you end up with that big 4x4 matrix, and trying to take that to the power of 7 to potentially figure out p sub 7 it looks like a nightmare, or like very difficult. And so that's what we're looking at, trying to simplify it to the a and not a thing. So we just have a 2x2. So you could just do that to power of 7. It might not actually be that bad, just doing that by hand. When you get it to a stable distribution, okay. Without when the entries are positive, give it some special properties. So I think I might just do this by hand because the Kaylee Hamilton thing, it's not like it can save you some time, but I don't know it myself, and I'm kind of interested to see if we can kind of take FizzBuzz's. Oh, hey. HA Change, thank you so much for the raid. How's the rest of the stream? Shadow, good to talk to you again. For anyone who doesn't know, HA Change was playing some Factorial. I was hanging out there before. It turns out HA Change and I have a pretty similar taste in games, it seems. There's like Factorio, Hollow Knight. I think I've seen some Ori and the Blind Forest happening and other games like that. Go check him out. I did notice he's not an affiliate, so if you want to help out a small streamer to get the offer of affiliate, I don't know if that's a goal of his, but go hit follow, lurk or chat in there to be a viewer. It's just a nice thing to do. So yeah, Fergus come in. We're working on this problem that's at the top of the screen. I think we figured out a technique to do it using Markov chains, and we've got quite a few calculations to do by hand here. So wait, how do we interpret, or how do we translate from the matrix to the possibilities that are given? That part I'm not so clear on. Is this, I guess, just that entry up there is our PNs? Took 3 hours trying to solve it. Oh, for your integral, Joel? Yeah, there might be an error in how the problem was written, because the integral shouldn't be that difficult. I'm going to call this matrix M. And I think we potentially need to go as high as m to the 7. Cedric? Let me write down what your problem is. Does your problem look like this? I know it's hard to format things in the YouTube chat, so that's why I want to make sure I'm clear on what you're asking. Yeah, I can help you solve this, if that's what it's like. Oh, why did I multiply the 4x4 with this? Check the matrix satisfies. Oh, really? The 2x plus 2 is both in the exponent. Oh, it's like that. I can probably still do this. Probably need some logarithms in our life, but we can do that. You don't need to solve it, you just need to check if the matrix satisfies the equations from the options. How? But like I'm still not quite clear on the relationship between the entries and the p's in the problem. Do we only care about this one? Oh yeah, we do. We only care about that one. You need to check if the matrix satisfied 729 n to the 7 plus 243 n to the 6 equals 241. Okay, is the identity. And so are you saying that we can do some factoring there? Use Haley Hamilton. Or Kaylee Hamilton. You think problems not designed for actually computing the matrices? Maybe they do want you to use Kaylee Hamilton. I just don't know myself, and it sounds like Colda doesn't know it either. So I wanted to avoid it, but oh, you do know Kaylee Hamilton? Oh. That's what this is, apparently. I've never done it myself before. But, it would have... I think we care just about this entry here because it's the probability of starting at A, which we're given in the problem, and ending at A, which is like what the problem is asking us to do. So apparently Kaylee Hamilton says P sub n, or at least just a piece of Kaylee Hamilton. I assume there's more to it than this, but we only care about P sub n, which is that entry there, I think. Minus a third to the n. Placing factorial, no one else I know. You're right, normally playing factorial. Oh, fair enough, HA change. It's close enough. I appreciate it. Two by two characteristic. Be that. Huh. Okay. I don't know how you would go from that to this, but apparently you can. Wait, do you need... Wait, so, okay, I kind of use those ideas as saying... Check if the polynomial 729x to the 7 plus 243x to the 6 minus 241 is divided by the characteristic polynomial of the matrix, which is what Colda would have just said. Maybe these are x's. Like that? It's a lot of math to do here still. Someone else is saying that's not me. Oh, okay. Oh, right. That is what kind of easiest idea said. Or wait, no. I don't know. The idea will work. No, you're completely fine. There aren't many thoughts going through my head, in general, to be honest. I can't explain where this equation comes from, Cayley Hamilton, but that we apparently can solve for K1 and K2 if we know that P0, said P0 is 0? No, P0 is 1. Oh yeah, duh. And we'll let as n goes to infinity, a Pn is a fourth, which you can kind of, I guess, tell intuitively by knowing there's 4 vertices, and you would think there's a more or less equal chance of ending up at any one of them. But using these 2 initial conditions, you could solve for K1 and K2. To have 2 equations, 2 unknowns. Oh, okay. P infinity would give you 1/4 equals just K1. So that implies K2 is 3/4. So the matrix, so the thing we care about from the matrix is this entry right here, because it's a probability of starting at A and ending at A, which is what the problem is asking us to think about. And right now it's 0, but if you take higher and higher powers of the matrix, it'll eventually become the probability that you want. And so the problem is asking us to think about like the 7th turn or the 6th turn. And so you would have to take this matrix to the power of 7 or 6 to find that out. But we're trying to avoid having to do all those calculations by hand. That's kind of like what we were talking about with this stuff down here. And so then I guess we can figure out, the first thing we have to think about is P4. We should get P4 through P7, I guess. Annoyingly. Uh... 3 to the 3rd is 27. 27 times 4. No, let's factor the 1/4 out. That's easier. Like that? So that's 28 over 27. So 7 over 27 is P4. $28 over 108. I think our answers agree if you cancel the 4. There might be more, because this will be a pain to plug back into the original things. There probably is a slicker way that people are saying, or like people were suggesting before. I just like, this is pretty like uncharted territory for me, so I'm doing things kind of like the tedious way. Oh, no, we're wait. Wait. I messed up the negative sign. there's still a -1 to the just n. And so that means we have minus now 1/81. (20/81). So actually, hold on. What I believe, I'm realizing this taking me maybe longer than I was hoping for. Would I be able to leave the rest of this to you? Because from here, it's just like I would just calculate P4 through P7 and try to figure out which equations are true. And I'd like to be able to think about some of the other problems that are here. Okay. Yeah, sorry, I can't take it all the way home, but I should look at this exponential, and I really do want to get back to Papadoria's question. Cedric, are you still here? Okay, so let's look at your exponential equation then. If you want, I can if you want screenshots of this, let me know, Colded. You can suggest a source. I don't have a source for Markov chains offhand. I would just type Markov chains into Google. That's kind of like the best that I got, unfortunately. I'm sorry. No, there's no such thing as an easy problem, Cedric. In this one, it's a little bit weird, to be honest. I'm trying to figure out the cleanest way of doing it. Took it in the SAT, I think in 1860, and I took it back when it was out of 2400. Okay, so I think what I want to do here, I know that 27 is a power of 3. It's 3 to the third. And that 1/3 is 3 to the -1. And also 9 is 3 squared. So it's kind of like everything is in terms of 3 here, is what I'm noticing with this equation. So I think I want to kind of write everything in terms of 3. You could definitely use log here too, Abel. I think we can actually avoid it though. I'm going to say that 1/3 is the same thing as 3 to the -1 to the 2x plus 2. 9 is the same as 3 squared, and it's still cubed. And 27 is the same thing as 3 cubed to the 2x minus 1. And the point of doing this is that we have exponent rules that say a power to a power like this, the exponents multiply. So 3 to the -1 to the 2x plus 2 becomes -1 times 2x plus 2, so -2x minus 2. Same here, 3 squared cubed, you do 2 times 3 is 6. 3 cubed 2x minus 1, you get 3 to the 6x minus 3. You got here's after this, you don't understand? Okay, nice, to even get that far. The next step is I want to divide out, I guess, this power from each side. 3, and you'll see why, or it'll be more clear why we do this in a second. So on the left side, these two things cancel. So we get 3 to the 6. On the right side, it's the same base. Oops, there's a minus sign there. And so when you have the same base being divided, the exponents subtract. So this is the same thing as 3 to the 6x minus 3 minus -2x minus 2. And we can simplify that. 6x minus -2 is 6x plus 2x, which is 8x, minus 3 minus -2. is -3 plus 2 is -1. And now the real kind of like magic we can do here is we have 3 to the power of something equals 3 to the power of something. Let's just set the powers equal to each other. So we should know that 6 equals 8x minus 1 in order for this last line to be true. And now we just solve this for x. So we add 1 to the other side, divide by 8, and we get x equals 8 over 7. So I think that's our answer there. Can you help with integral? Yeah. And just because this is a funky problem, I am going to quickly plug 8 over 7 back into the original problem. Just to check the answer. There's annoying fraction math. Very nice person? Oh, thank you. Never mind, that's too annoying to check. I'm gonna plug it into Wolfram Alpha. (27 to the 2x minus 1). (7 over 8). Wait. I got 8. Oh no! Wait. I did the finals. Oh my god, I just tripped at the finish line. It's 7 over 8, not 8 over 7. Oh my god. 7 divided by 8. That's okay. I'm glad I. Yeah, I can do calculus, but not algebra. I'm glad I checked that. Scrap it, stall over. Yep. The 20/22 derivative of e to the x sine of x evaluated at 0. I know you can make a formula for that, Cytos. Because you're going to get terms grouping together. There's a few too, or there's some other problems that have been asked first that I wanted to think about though. So Papadoria quote is saying that you need Leibniz theorem for that. Papadoria, are you here? I think we're on to your problem finally. Again. Type your name in chat too. Actually, until I see Papadoria reply, maybe I will see if I can do Cytus's problem quickly. Because I feel like that's what I actually know how to do. You have to calculate a couple derivatives so we can see the pattern. Hey, Sarufu. Yeah. But hey, I'm here to help people so they hopefully don't have to think about math. Math is inevitable. Oh. That's a very helpful idea. Yeah. That would make the derivative business easier. Sine It's like e to the ix minus e to the minus ix over 2I. I need to check the sign in the middle. That's it? Okay, thank you. I can never remember it. Too bad, but you have to progress. Fair enough. If you have a question, feel free to ask it. I'm just here to hang out. You're more than welcome to do that too. Okay, so this derivative, I mean, this is still a little annoying, right? I mean, we could already generalize the derivative from this though. Now that I think about it, because it's just going to be 1 over 2I, I plus 1 to the n, e to the I plus 1 x, minus 1 over 2I, 1 minus I. We should put these exponential, or these complex numbers into exponentials themselves. We're evaluating at x equals 0, which also helps. The worst are, oh, like proving a theorem? Those are definitely annoying. Yeah, horrible. I That's definitely a weakness of mine. I'm not very good at it either. Makes you feel better. For some people, that's like what they live for. Like they love it. One minus I. Why is that so hard for me? It's quadrant 4. It's 2 pi minus pi over 4 is 7 pi over 4. I guess 1 over 2i, I should have... rewritten like this. Got 1 over 20 for 2 exams about it. Oh no, you retried and got 8? Alright, that's an improvement at least. Can I compute the kernel for phi z to z such that phi of 1 is 12? Oh, it seems like an algebra thing? I'm sorry, I don't know how to do that, Alex. Someone around here might know. Paste it over into the Twitch chat as well in case someone over there wants to like think about it, but I don't know how to do that offhand. 4 does not go into 2022 evenly. No, I can't. Yeah, same. Abstract algebra? Okay, yeah. Uh, okay, but minus pi over 4 is way better coded. Thank you. I was just getting confused on that exact piece. All right, see you, Sarufu. Thanks so much for popping in. Oh wait, you know what? If you're interested in math streams in general, like if you ever need help, here's a whole list of people who stream about math. And I know that Penn Center speaks some French in particular. So if that's helpful for you, then there you have it. Please depression? Yeah. uh I don't want to speak for him, but he's open about his like I guess like his mental health journey, I'll call it. Hey Phobos, how's it going? So we can translate this back into a sine, right? That's the point of doing this. I should have left it as 1 over 2i. Ugh. This is the same thing as root 2 on the outside, fraction bar, e to the I, 1011 pi over 2 minus e to the minus I, or not necessarily sine, it could be cosine. This is sine though. Now you're done with work. Nice, nice. So root 2 sine 1011 pi over 2. And surely we can simplify that. Or like the sine of that. It's root 2 to the power of 2022, you're saying? I'm not getting that. Original way is a little better. The fourth derivative is minus 4 times f of x. Oh, really, Bluebird? Oh, I did make a mistake. This is root. Yeah, that needs an n. And I think this way will work after that. Maybe. You're right about that, Colden. Root 2 to the 2022 is also 2 to the 1011. What is this, pi over 2 or 3 pi over 2? That's what I'm trying to figure out. Without having subtract off 2 pi like 500 times. You take it mod 4? Yeah, that makes sense. Oops. Okay, it's 3 mod 4, which means it's 3 pi over 2. Which means it's negative. I guess that's my answer? Minus 2 to the 1011 was correct? Nice. Yeah, I think of the non-complex way is also fine, but I haven't done this a problem like this the complex way, so it's interested to see that. Feeder, the derivative, that's a weird derivative. Cotangent n minus 1? Sine x log x? Like over root 2? I don't quite know what you're... This is a weird thing to take the derivative of. Like you're taking derivative in terms of x? But there's two variables here, like in terms of x or in terms of n. I assume x, but like this is just a weird thing, I guess. In terms of x, we can do it. I would take all of this garbage outside of the derivative because it doesn't have x inside it, so let's not worry about it. Inside the that's a product rule. So I'm gonna take the derivative of sine, which is cosine, multiply it by the original of the other thing, log x. Now do plus, and then take the original of the left one, sine, and multiply it by the derivative of the log. And I assume that's log base 10. So the derivative of that is 1 over x times 10. Or no, times ln 10, I want to say. I don't have that derivative memorized. You can find it using the change of base. Okay, yeah, no, I got it right. So I'd say that's your derivative, I guess, Peter. Okay, I feel bad that I've been ignoring Papadoria's problem. It's just really tough. So, if you're watching on, I think on Saturday, you may have seen this problem come up. And we kind of started on it. We solved part B. Part D, we started on but didn't get very far. Papadoria made some progress on part D by finding a simpler representation for S of x. But still trying to integrate it is pretty freaking difficult. So I don't think Papadoria is here, but I still want to think about it because I feel bad. So I'm just gonna repaste the question into chat so I can scroll down. Papadoria found these two representations. They both represent the sum equally well. The second one looks easier to integrate. So that's what I was trying to figure out. Integrating just the floor of x is relatively straightforward. Integrating that thing, who the hell knows? And so we were messing around with... I started by splitting up the integral into two separate integrals, because that's just like a reasonable thing to do. And then I liked trying to split this summation out and think about integrating term by term. Because This might need a different summation than that one needs. And I'm trying to figure out what that summation is, though. And this might collapse back into a double sum or something. That's what I'm expecting, at least. I'm expecting it to follow a pattern. But if we looked only at this piece of the problem, how would we split that up? It's kind of difficult because of the 10 that's in there with the power of the ceiling of a log. Oh. Oh, Colder, that's a good point. The exponent has infinitely many discontinuities from 0 to 1. That might make this a non-starter. Because we would need to get rid of all those discontinuities before we can think about integrating. And just like, if the ceiling didn't exist, the 10 and the log would cancel, and that'd be so nice to do. But the ceiling breaks that on purpose. It kind of has to not work. I mean, you only have to care as much as you want. Seems to be removed from all houses, they just get in the way. True, Cytos. What is a non-piecewise function? Uh, that's a fair question, Lubert, because wouldn't you consider the floor and ceiling functions both piecewise? Or they may as well be piecewise functions. But there's no way there's a simple like definition for like S of x that doesn't involve ceilings and floors that I can think of. It's a lot of programming things. Hey, critical. What is it? Ordinary differential equations? Yeah. A different kind of function. Yeah, I guess so. Back tomorrow? I won't be doing math tomorrow, but okay. On Saturday? Okay, that works. Yeah, so it's like that part I'm not so clear on what exactly they would count as a piecewise function. What a crazy formula. Time is it? Okay. Got class tonight. Can you integrate when mod is involved? I might need to give up on this problem. Yeah, I don't know. I kind of want to do some analysis, studying. Um. Oh wait, where was I in this file? Was I? Okay, yeah, I was done with that physics problem. Um, what was up with the analysis? Where do we end off on mod? Is the same like issue as floor and ceiling functions? Okay. Did we do 5? I think we did. Didn't we like leave some homework though or something? Hey, it's G1. Let me bring up our thing, our whiteboard from this meeting. Okay, I think we answered 5 fully. So let's look at 6. We have smiley face of X. She had time to even look at this homework. This is basically the only time that I have. I usually just like too tired to do setting off stream. Infinite series representation for this function. Well, I'm skipping ahead to B, but I do notice this is the derivative of arc sine. But that doesn't help with part A, I don't think. I think well how we should maybe think about it uh like this. And then on the inside, we can plug in the series that we know. Because we know 1 over 1 minus x is a geometric series. And so if we have an x squared, that becomes an x to the 2n. Well, that's not... I don't know that this counts as... the right answer, though. I don't like the 1/2 being outside of all this. That feels like against the spirit of how an infinite series should look. Like the summation should be on the outside. Yeah, you're right, Colton. I should do that. Because that's the other thing that we learned in this class, or in the class that we just like. It was just on the same worksheet. I need to look back at it though, because I don't remember the formula. And the series for x to the 1/2 and plug the geometric series into there. True. Where do we do this? That's our formula. Oh wait, no. We for the weird indices. It's more like that. Either of these. I want to do both of them. Hey, mathematician. X squared to the k. Yeah. But we also have a what's the question, mathematician? We could also make a series that is like that. And these just have different intervals of convergence. I think you normally only look at the first one. I feel like that's the default one that most people use. But I like to see them both. And so a series for arcsine. We can take the derivative of these series. Smiley face prime. Like that. Let's check these in Desmos. If I can figure out how to work Desmos with summations and chooses at least. Sum. Okay, that's helpful. N equals 0 to some constant A. Choose. I might have these reversed. I don't know which one comes first. 2kx to the... Oh, n. It's NCR? Okay. Wait, Really? Like literally, N. I assume you have to put in parentheses then. And oh my god. Okay. Thank you. That's not good. It's like an M. I see that result sheet. That's weird. I don't quite know what to think of that, to be honest. Hey, Suna. Oh, okay. I mean, I'm trying to derive it a specific way, colded. It's like a way that's in line with like there's a class on Twitch that's been happening, and I'm trying to derive it in the way that's like in line with the class. That is good to have too. I'm doing well, Suna. Thanks for asking. And yeah, I do have it's a very funny curve here. Trying to figure out why it doesn't. Oh well, that's an issue. It's not the what? Desmos. Okay, that kind of helps. It's because there's still an X inside this summation. If there is a negative, oops, that would almost be what we want. Kinda. But there's not. Did I miss a negative? I don't think I did. Why is this wrong? Why does my other series look, I guess? Why isn't this being graphed? Hello? Desmos, wake up. Graph it. There you go. Oh my god. Oh, it doesn't work. Zach was... Okay, let me pull up a thing that Zach did. Because Zach was graphing these somehow. Maybe they didn't involve choose, though. That doesn't involve choose. No, apparently it works. Just find out what the answer is and work from there, I think. You do need to think about this. Or, okay, wait. Oh, I integrated it. Or, I mean, I took the derivative. Ugh. Um, bruh. I should have done this. I'm messing it all up. That's what I'm doing. All right, let's try that. Stop it. No. Wait. +1. +1. -1 over 2n. That's not good. The red is MIA. The purple is not quite right. Colded, you're saying Why is there a -5? Or I'm not sure what you're doing with that, with what you posted. I could do that too, Cytos. I just want to be told the answer though initially. Or at least I want to. I want to just. I don't know what I want. I mean, I could just do the formula with derivatives. Well, no, that's kind of a pain. God, I gotta use the bathroom so bad, guys. I'm gonna be right back. Sorry. Okay. Hey, mathematician. In the future, can you put it in like the math discussion of the homework help? Channels. Either one of them works. Well, I can see immediately that if you were to fill in, say, that entire circle, just to choose a random one, that's a terribly drawn circle, but the point is that the center of it is right here, and that means that this 20 length is also the radius of the circle. So that can help you find the area of the entire circle, and like this entire, well, not half, but like you can find the entire quadrant of the circle, I guess, with that. Hey, Manil. Feel free to post your question. Um, Either you can put it right there in chat, or if you do a screenshot, you can post it in my Discord. But getting the overlap, I'm still not. I'm still trying to think about. We could also divide up the square into 4 pieces. And we could try to find just this region here. Calculus? I'm sure there is. I assume you're not supposed to use calculus though, right? Because anytime you're trying to find area, you can use calculus for like a geometry problem like this. It would take a bit of work, but you could do it. I'm looking for a geometry way of doing this, though. What I come back to? A weird geometry problem, Jasu. I don't really know where to even start with this. Hey, syntax. A real tough problem? Sure. Be nice, Cytos. It just feels like I have the same exact issue. Oh. Well, I don't know. We could find, like, this area. and like subtract out these two pieces, how would we go about finding that area and that area though? Hmm. Just find the area of one of these? If you can do that, the problem is easy. Is it? I don't think so. I don't see what happens after that. I don't know how to even get that piece. Indian Scouser. I mean, I don't know how to check if that's the answer, but Indian Scouser is calling that the answer is, I assume, like that? Or no. I I think like that. You just cracked a Jasu? Oh, please tell. Um well yeah, so I know how to get this entire area here by doing what you guys are saying, I think. I just don't know how you use that. We can do it if it sounds like it's gonna be a helpful thing, but um oops. I guess like I can see that rotations piece. I don't know, but like the kind of rotation that happens, I don't know. I just don't know. The area, I guess I'm gonna call it like I because like this feels like an I shape. And we multiply it by 2. Wait. No, 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 no. We would do 400 minus 400 minus 200 pi. Is that it? No, oh my gosh. Ugh, hey, finished. What do you have for dinner? I'm probably eating. We're just gonna eat freaking brown rice and lentils. Just nice and easy. Uh, into the k over n factorial. What the heck? What is t in that syntax? Indian Scouser is saying 4x plus 4y plus a shaded equals 400. Tuna salad kit range flavor. Nice, nice. 2x plus 3y plus a shaded. I don't know what x and y are yet. I'm just copying down what Indian Scouser is saying so far. Pi times 400 over 4. Equals pi times 400 over 3. No. Minus root 3 over 4 times 400. And so I assume like x is going to be maybe that bit and y is that bit. Or to have it reversed. Oh, Tvex is the... Oh. I'll have to look at that more after this problem syntax. Divide them into x, y, area of shaded region. X is one symmetrical part, y is the other symmetrical part. Oh, maybe it doesn't matter which one, but surely matters which one with the 2x and 3y. X is the smaller one? Okay. So then x is that right there. Y is that. Okay, and so I can see how the first equation comes about, because that's the entire square. The second equation... Okay, is the entire square minus, say, that bit up there. And then the last equation is this. Uh, which is the area. Oh, it's not quite the area we just had. Third is like you draw an equilateral triangle and take off one quadrant. I don't see it in this picture, but like you're talking about like if you took off just that piece of the equilateral triangle. I don't see how that's related to what's happening in the third equation, though. Hmm. Oh, so you're drawing an equilateral triangle maybe like that. Does that even work? It shouldn't be that tall, right? Is it that tall? Oh, so you have two half Ys. Maybe. No, no, it's not that. Each curved arc of the shaded figure subtends a 30-degree angle at the opposite corner of the square. That might be a. Oh, is that a better way of thinking about this? Hey, Raven. Just struggling with geometry, the usual. Hope you're doing well. I'm not following this, I'm gonna be honest. Okay. Oh no. That sucks. Right, I see it's only one of the quarter circles. Um, oh, I get what you're doing now. Okay. Do I get it? How do you possibly have a 10 root 3 distance here? Um, when the entire length is 20 and this is less than half of the 20. This entire length is 10, isn't it? Oh my gosh. Okay, I was looking at it wrong. I thought you divided up the entire square into fours. This is the entire square, but you only drew one of the arcs. Okay, never mind, never mind, never mind. Sorry. I was getting mixed up because there's the 10 up top there, but I realize now that's only for like the half length. Do you get Huz? I don't know what that means. I guess I don't. I don't know. I feel like my brain is crashing right now, I'm gonna be honest. I'm having a hard time just like thinking now. Okay, so what Cytos did is basically find like that piece there. TikTok, I just don't like going on TikTok for myself. I think you go on live stream on TikTok, you have to post a good amount of content first too. Like you have to grow to a certain amount. I don't remember though. I think it's what Cytos found with what the math we were just looking at. No, math position. Um, I think I hit my limit, guys. I can't think anymore. I'm sorry, mathematician. I just can't do this right now. Brain no worky. Um, Sorry. I'll try to come back to it at another time and get back to you on Discord. Thank you for the help on this, both Indian Scouts on YouTube and Cytos. Yeah. I'm gonna have to revisit this with a fresher mind. Integrate it. I feel like I could actually, like, I do have the brain power to integrate it, but I don't have the power to do this with geometry, and I don't think an integration answer is what mathematician is supposed to do anyway. I have an answer but got messy nested radicals in it. Any discussor is calling that this is the answer. I have no way of verifying it, but apparently you can set up this system of equations and solve them. I still can't understand where the third one comes from, but it's something about equilateral triangles I couldn't quite puzzle out. Just cross-checked. Okay, Indian Scouser is doubling down on this being the right answer. Okay, yeah. I think I'm calling it because I think I'm all mathed out for now, and I got to do the real analysis class in a bit over an hour, so I need to be at least have some math juice left for that. So message, I'll try to get back to you on Discord. If anyone else comes with a solution before me and feels like typing it out, it is posted in my Discord in the general chat and the welcome chat. But I'm gonna call it here for the day. So I'm gonna put the YouTube stream up here. So anyone here on YouTube, thanks for being here. I think the answer is far too small, really. I don't know. Yeah, see you later, Colden. Goodbye, YouTube.